In Chapter 1, we built the map of calculus. We saw four words: functions, limits, derivatives, and integrals. Now we begin with the first one, functions, because before calculus can study change, it must know what is changing. This chapter is about the machine of mathematics. Here is the question for this chapter. What does a function actually do? And why does calculus need it? The answer is simple, but very important. A function is a rule that turns each input into exactly one output. That sentence is the foundation of everything that comes later. Think of a function as a machine. An input goes in, the rule acts on it, and an output comes out. For example, suppose the rule is multiply by 2, then add 1. If the input is 1, the output is 3. If the input is 2, the output is 5. If the input is 3, the output is 7. The important idea is this: each input must produce exactly one output. If the same input produces two different outputs, it is not a function. Now we need notation. When we write f of x, we are not multiplying f by x. We are saying, the function f receives the input x. The result is called f of x. So f of 2 equals 5 means, when the input is 2, the output is 5. Function notation is just a compact way to talk about input and output. Functions are not only abstract symbols. They appear whenever one quantity depends on another. Time can determine distance. Radius can determine area. Hours of study can affect a score. In each case, one quantity is acting like the input. Another quantity is acting like the output. This is why functions are the language of change. A graph is a picture of a function. Every input-output pair becomes a point. For the rule f of x equals 2x plus 1, input 0 gives output 1. Input 1 gives output 3. Input 2 gives output 5. As more points appear, a shape begins to form. The graph is not separate from the function. It is the function made visible. Different function rules create different shapes. A linear function creates a straight line. A quadratic function creates a curve. An exponential function grows very quickly. Later in calculus, we will study how these shapes change, where they rise, where they fall, where they bend, where they become steep. That is why functions come before limits, derivatives, and integrals. Now we must be careful. Not every curve is a function. For a relation to be a function, one input must give exactly one output. On the left, the vertical line touches the curve once. That is allowed. On the right, the same vertical line touches the curve twice. That means one input gives two outputs, so that relation is not a function. This is the basic idea behind the vertical line test. A common mistake is to confuse the function, the equation, and the graph. They are connected, but they are not identical. The function is the rule. It is the process that takes an input and produces an output. The equation is one way to write that rule. It is the compact symbolic language. The graph is one way to see that rule. It turns the input-output relationship into a picture. A strong calculus student learns to move between all three views: the rule, the symbols, and the picture. Chapter 2 gives us the first real object of calculus. A function takes an input, follows a rule, and produces an output. Each input must give exactly one output. Graphs show input-output pairs, and calculus studies how functions change. But now a new question appears. Which inputs are allowed? And where can the outputs go? That is the next chapter, domain and range.